So good morning, all of you. We met yesterday. You were all new, nearly all of you were new to me. I will talk about invasive tree species, but I will mainly concentrate on the question if they are always invasive and what we can do to make them less invasive. It's a pity I have to present this here in this room. Not that I don't like the room, but this is typical topic you should discuss in the forest. Anja Bindewald and I went for a study trip to Ticino Valley Parco Nazionale for some days before we came here. And all of the species I'm going to talk about, we saw them in huge amounts, very large populations. And there you could easily see in what conditions that these species were invasive and where they were not. So I will try to explain this on the paper, I would say, but on the presentation, without having the forest to show you to you. I'm doing this work behalf of a live project we are doing in the Netherlands on the ecosystem resilience approach. So what we are doing is preventing dominance of invasive alien species by strengthening the resilience of forests and nature. So I'm not only working in the forest. Me, myself, I'm concentrating on the forest, but my colleagues are also working on water plants, on fishes, and on the Fallopian. So, invasive tree species, the problem. There is a lot of influence of non-native tree species on the habitats where they are growing. And if this influence gets large, we tend to call this invasive tree species. Non-native tree species have, just like native species, a lot of influence on their habitats. They influence forest structure and composition. They disturb sometimes desired forestry goals. Typical example of this is that we put very fixed Natura, how do we call it in English? Nature 2000 goals on forest, and sometimes they're that static that you can't really work anymore on your really biodiversity goals. Invasive tree species can influence the forest succession, but this is mainly the case in semi-natural habitats, in grasslands, dunes, wetlands, in open forests. Invasive tree species, they take over the space, and instead of these spaces being open, they turn into forest. And a lot of times this is not really the aim. So if we would be thinking about introducing new tree species, this invasiveness is an important part of a risk assessment. I've seen you have been working a lot on risk assessment in this project, and I also saw them in your management book about non-native tree species. So I think you all know enough about it, that you always have to work case by case, side by side, and goal by goal, and never say we are putting all the invasive tree species on one heap and we decide about them. So the widespread is invasive tree species in this area. I like very much the paper of Campagnaro and his colleagues, and they selected the 5 main invasive tree species: ashleave maple, tree of heaven, black cherry, red oak, and black locust. Exactly these 5 tree species we have been able to study in the Ticino Valley also. I was hoping to find them also here around, but I already understood from Nicola that they are not that dominant in this region. These 5 species I'm going to talk about, they are already widespread in Europe. I show you this map of black cherry, and then you see that there's a concentration of black cherry in Belgium, where it's orange. But then you see at the same time that at the border with France, their black cherry disappears. So this means this kind of maps, they only show where somebody has registered the presence of the tree. These trees are much more widespread than these maps show. You can see the same at the frontier between Germany and Czechia. Also there, suddenly black cherry disappears, just like if they stop at the border, which is of course not true. Red oak, black locust, you would say it's really a European tree, this one. Ashleave maple, still less spread. And then the tree of heaven, Ailanthus altissima. Did I forget? Yeah. So when we look at the traits of invasive tree species, then we see that important things are they have an abundant seed production. They start producing seed at a very young age. They're easily dispersed by wind or by animals, and they have a rapid juvenile growth. But on the contrary, invasive tree species, they need a lot of light to establish, and they're mostly short-lived. And when you look at these traits with a forestry ecological background, what you see is exactly the traits of pioneer tree species. So we did a research on, especially on the black cherry. We published this book in 2013. And actually our conclusion was that black cherry and also these 4 other tree species that are actually acting in the forest as a pioneer tree species. When you look then at this, this most important trait, the light they need for establishing, you find these 5 invasive species on this list. And you see that black lotus needs more or less the same light for establishing a Scotch pine. So we put it in what we call the pine group. Then you have the oak group. In the oak group, where Quercus robur and Quercus petrea are, you also find tree of heaven, black cherry, and red oak. So that means these 3 species need more or less the same amount of light as these oaks and ash and aspen. Then there is an exception in this invasive tree species. That's the ashleave maple, because it supports a lot more shadow than the others. I will come back to this. This list comes from Nienemets and Valladares. It's a very interesting study. And if you are talking about invasiveness of a tree species, you should learn this list by heart. It's the key to understanding invasiveness in forests. But then there's often, we hear that tree species or other invasive species are only invasive in their new range. I was very happy to find this publication, this book by Etienne Brocard and Fried, that studies invasive species. And they found out that a lot of, not to say all of invasive species are at the same time invasive in their native range as they are in their new range under the same conditions. Examples are common ragweed and giant hogweed, but also the 5 tree species I'm talking about: red oak, black locust, ashleave maple, tree of heaven. And then I will broaden this a little bit with the example of black cherry. I have been studying black cherry in the United States, especially in the very deep, poor, dry, sandy soils of New York State. And in this area, in 100 years ago, 150 years ago, 80% of the area was agricultural land. And now 80% of the area is forest. What happened? When the farmers abandoned their land, black cherry took over the abundant land. So it was invasive. It invaded the abundant agricultural land and took it over and made forest out of it. And after black cherry came then the maple trees and the beeches and the lime and the linde. So this invasive characteristic of black cherry was very, the Americans liked it very much because they wanted to have forest again there. When this tree does the same in Europe, we dislike it. So are we talking about invasive species or are we talking about pioneers? In these pictures, these young people, they are removing Scotch pines and silver birch from heathland. It's something we do every year again in our management of heathland. We take out the pines and the silver birch because these pioneer trees are trying to convert this heathland into forest, but we never call them invasive. They are invasive in this situation, but we never call them invasive just because they are native. Again, a picture from Germany, after a clear cut, you see a pioneer species, mainly silver birch and black cherry. And these pioneer trees are making a forest again after clear cuts. What would we say then? That silver birch is a pioneer tree species and the black cherry is an invasive tree species? Sounds a little bit strange. And then something very important that we saw, that the pioneer black cherry, they cannot succeed itself in the forest if the forest is mixed and if there is a lot of structure in the forest. Then what you see, the old trees here are black cherries, and then underneath the black cherries, if the seed trees are present, we see establishment of native shade tolerant species. In this case, most of them are sycamore maple. Now, another thing about this rejuvenation of black cherry, this is in New England on the sandy soils I was talking about. This very proud forester here, he showed me this forest and he gave me this table. And then you see when they make the inventarization of the rejuvenation, when it was like 10 or 20 centimeters high, they had only 3.58% of black cherry in the rejuvenation. Mostly it was soft maple, they mean red maple, 20%, and then still more 10% of browsed red maple. And you have a lot of American beech. So they had only 3.58%, while at the same time, the black cherry was still standing underneath the regeneration. This is the normal situation, that if the seed trees of the other species are there, black cherry has very difficult to establish. But these Americans, they had a very good solution for this problem, because they want to have 100% black cherry here, because for them it's a very important production tree. So they sent a company in there with glyphosate on the back, and they killed just all the tree species present except the black cherry. And what you see in this forest now, 10 years later, they have a 100% cover of black cherry. So if you want to keep black cherry in a mixed forest, you have to fight the other tree species. Okay, what makes invasive tree species invasive? Let's think about a system in which we have, let's say, three variables: the moisture, the nutrients, and the light. And in such a system develops an ecosystem filled with organisms, plants, animals. And if there is a disturbance, you lose a part of these organisms. For example, after a clear cut or after combating black cherry, and then this ugly non-native species that take over this space. So you create a niche for this invasive or pioneer species. Also change. In the change, you can lose a lot of organisms. And when you think about change, about climatic change, it gets drier and hotter, so the system changes, and there's a lot of open space that can be filled by these ugly boys. For example, we think that the Ailandus altisma, which is not present yet in the forest where I'm coming from. You don't see them in the forest, only in the cities as park trees. we think by climate change, if the present trees like the pine and the beech and the oak will die, probably ailanthus can take over this space. Good. So what conditions make invasive tree species invasive? We can say that they can be invasive, this pioneer tree species, when there are unused resources. Mainly we're talking about light, nutrients, and moisture. So this means unused resources means that there is insufficient competition from other organisms for these resources. And the main resource for the potentially invasive or pioneer tree species is light. That's why I showed you this table before. And I show it again to you. Really study this table if you want to go into the forest and understand why there is invasion of non-native tree species. So what forests are invasible then? Mostly we are talking about poorly structured, unmixed forests with a translucent canopy, or forests which are regularly disturbed by clear cutting, by coppicing, by flooding, by storm, by extreme droughts. So all forests in which there is a lot of light that reaches the forest soil, and which makes it easy for pioneers to establish. Two examples. In where I come from, in the Netherlands, Belgium, northern part of Germany, on the sandy soils, we have a lot of pine and oak monocultures. There were former plantations. They're very easy to invade by these tree species. But also forests recovering from overexploitation and deforestation in the past. The forest where we were in the Valle del Ticino, until 70 years ago, there was no forest. It was nearly bare land. And when this forest recovered, these non-native tree species, they were present in the neighborhoods. And the forest development was a combination of native and non-native tree species. But as these non-native tree species have a strong pioneer character, of course, they are the first to fill this space. So, which forests are invasible? You could say far from nature forests. The more close to nature forests are, the less invadable they are. This is an example from our pine forest on the sand belt. This is in the Netherlands, but you can see exactly the same through Germany into Poland. On huge surface, black cherry underneath the pines. This is in the Valle del Ticino. As I said, what you see here is not an invadable forest because there is no light anymore at this moment. But the tree standing here is a mixture of native and especially a lot of non-native tree species. And now if you are going to make a clear cut or a group cutting in this kind of forest, you get a lot of regeneration of these non-native species, like you see here on our field trip. This was a mixture of black locust and black cherry, and the management decided to eradicate or to cut at least all the black cherry. And what you see now is a cover, full cover of black cherry underneath, and you are back to zero because all the black cherry will grow up again and grow to the crown. So for this reason, because it's so complex and to combat it, and we can't get rid of these invasive tree species, that's the reason why we started thinking about a solution with this ecosystem resilience approach. So we try to restore and to manage forests to prevent invasive tree species to become invasive. We are convinced that invasive tree species, they are just pioneer tree species. And if you have if you want to reduce the population of invasive tree species, you have to move away from pioneer situations. That's the clue to the solution. we use this definition of Volcker for resilience. Ecological resilience is the ability of a forest ecosystem to absorb disturbances like climate change, to reorganize itself during these changes. So resilience means not that you get back to the same forest, but that the forest can change, but with maintaining the functions, the structure and identity and feedbacks of the system, but not necessarily with the same species composition. And if you then look at this resilience, you can see this resilience on different levels. Forests have a high resilience, also when it does not always every time look like this in a forest, but you have this resilience on several levels. First, you have the individual persistence of the organisms, in this case the trees, their resistance to stress and disturbance and competition. But when they get then disturbed, then there is the mechanism of recovery, the rejuvenation that reestablishes the populations after a storm, after a clear cut. And then there is in the resilience this transformation possibility or adaptation, that the system can adapt to the new situation. So persistence and recovery leads to maintenance of the composition of the ecosystem, more or less. And adaptation or transformation results in new ecosystems, and these new ecosystems that can be desired or non-desired. This is a very nice picture from this study by Falk and his colleagues. You can see these loops. The loops of persistence goes back more or less to the same after disturbance after not too strong disturbance to the same kind of forest. When you have severe disturbances, you get mortality, but if the trees have the possibility to recover, to reestablish their populations by the rejuvenation, you go back to the same, more or less the same community assemblage. But if the disturbance is too large or is going on too long, you can move into alternative states. Of course, these alternative states, they can be interesting. Shrubs can be interesting also, not only forests. But you can lose a lot of ecosystem services. And then there is this possibility of this transient reorganization, where you influence the process of after the disturbance or during the disturbance, and you influence that in such a way, for example, by planting other tree species, that the forest ecosystem still stays a forest ecosystem, but with a different species composition, but delivering the same ecosystem services. These forest resilience mechanisms that prevent invasive tree species from being invasive, you can see them on the three levels. On the persistence, what's very important in the persistence, this is the competition in time. These invasive tree species, these pioneer tree species, they are usually very short-lived. And the native species, the oaks, the pines, the linde, they live for centuries. So it's also a question of time. Then you will lose these pioneers. The recovery of the rejuvenation of tree species after disturbance. If this recovery happens under a condition with a lot of light, you get a lot of pioneers, so a lot of invasive tree species. But if this rejuvenation can happen in a lot of shadow, you get the shadow tolerant native species. So when you are managing your forest, this means never make large clear cuts or large group cuts, but then you will, because then you will stimulate the invasive tree species. And what you also see that underneath these invasive tree species, if the seed is present, the shade tolerant tree species can establish. And the other mechanism is the closer to nature, is the transformation. If you see that you can't or you won't go back to the former situation, you can stimulate this transformation by using a closer to nature forest management to preserve the forest climate. if you're thinking about transformation, or if transformation is necessary, you have to rethink your forest goals. And a lot of time you cannot work anymore with these fixed Natura 2000 goals. And what's very important in the transformation is the presence of tree species that can cope with the disturbances. The presence of species which can cope with invasive tree species and with climate change. I'll give you one example. This is an example on which I hope Anja and I will work together in the next years. In Baden-Württemberg, there is in the Rhine Ebene, in the Rhine Valley, there are very, very dry forests on sandy soils. And this drought is intensified by climate change. And what we see there's the silver birch, what was normally always in this system as a pioneer, it disappeared 10 to 20 years ago. When you go walking there, you nearly never see any birch anymore because of climate change. It became too dry and too hot for the silver birch. These forests are mainly former pine plantations, and the dominating Scotch pine is massively dying at this moment by Spheropsis sapinea. In Germany, they call it Diplodia pinea, induced by the drought. And you nearly don't see any healthy beech and oak anymore. So what's happening here is that the black cherry, black locust, and red oak is taken over the forest because of the dying of the native species. This is how this forest looked in the winter. I was there in the winter. You see the dying or the dead pines, and underneath you see the black cherry branches that are very happy to receive all this light. And this is how it looks underneath. So black cherry regeneration, red oak, black locust, and some beeches and some hornbeam. So in this situation, you have two pathways. You can just say, we let it go like it goes. Then you have the first pathway, no intervention, and then your pine forest will turn into a nice combination of black locust, black cherry, and red oak. Can fulfill some ecosystem services, but on the side of the very important ecosystem service of biodiversity, you will lose a lot. So if you don't like this, you can strengthen the resilience. That means that before this complete forest is dying, you already start introducing tree species that are resilient to this climate change. And then, of course, the pines will die too. But then there is a lot more species that can take over the forest, and not only these three invasive tree species. So what we have to do then is to, in this program that we are working on with the city of Mannheim and with the Baden-Württemberg Forest Management and the FVA and the university in Freiburg, hopefully when we get the project, is that we work on the three levels of persistence, recovery, and transformation. On persistence, we will select and release the vital young trees, because we saw that in between these invasive tree species, we still find some hornbeam, beech, sycamore, Norway maple, a little bit of oak, nearly no pine, and some lime trees. We will select them, give them freedom, and give them space, and let them grow through for making the new canopy. And where these tree species are not present, we will select vital black cherry trees. It sounds a little bit contradictory, perhaps, that we will select invasive tree species, but we want to keep the forest climate. You can imagine if all these pines are dying, and if there is nothing standing below, and we are still going to cut the black cherry, all the black cherry seeds are there, and we will get again a black cherry forest. So we prefer to keep the black cherry. Then we come to the level of recovery. We will stimulate natural regeneration. Like nearly everywhere, browsing is a huge problem. We have to find a solution for that. And the black cherry and the black locust that are still in the forest, that even those we selected, we will underplant them with oak, beech, hornbeam, and maples. And then you see you're still in this range of our more or less natural forest in this region. We don't use yet any tree species from Southern Europe. But we are also thinking about the transformation, because we know that if we select or if we plant oak and beech, they will have problems, because we already see this problem. So we need also other tree species. So then we go to transformation. This means, of course, this close to nature forest management to preserve this forest climate. Some goals will have to be adapted. In part of this forest, there are very typical open pine forest ecosystems as a goal. They will be very, very difficult to maintain in this situation, especially when the pines are dying. This will be a difficult discussion. And then we will underplant the selected tree species with climate change resistant tree species, just as chestnut, Tilia cordata, Tilia tomentosa, the Turkish hazel, Corylus colurna, the oriental beech, Fagus orientalis, which is a lot more drought resistance, and so on. And this depends, of course, always on a lot of political discussions, if there is willingness to introduce this tree species. But all these species I'm showing you now, they are not invasive at all. So now to my personal experience as a forester, and this is one of my last slides. The more light demanding an invasive tree species or pioneer species is, the easier the ecosystem resilience approach is. So black locust is very, very easy to cope with. It's actually no problem at all, as long as you adapt, if you accept the forest succession and if you stimulate the forest succession. There's so that much of light that it's. Black cherry is easy too. Red oak is a little bit less easy, because red oak supports a little bit more shadow and as a young tree, and it shades. It makes a lot more shadow when it's old. So the main reasons, the main factors are the shade tolerance of the juveniles and the shade casting canopy of the invasive species itself. Yeah, of course, we can see this again in this list. And then when we go then to the transfer of this ecosystem resilience approach to tree of heaven and ashleave maple, two tree species with which I do not have any experience at all. I saw my first tree of heaven forest Monday. Was it yesterday? Monday I saw the first in the Po Valley together with in our visit. And ashleave maple, I know the tree, but I never saw any large scale invasion of ashleave maple. So these two are new to me. So what do I think about these two? I think that tree of heaven will be very easy to integrate in forest ecosystems, as long as you accept the more dark forest type. And ashleave maple will be more problematic, and that's because of in ashleave maple it has a lot of shade tolerance. So when we are talking about ecosystem resilience approach of non-native or invasive tree species, again we have to judge it case by case, side by side, and goal by goal. Once that we know how to manage these invasive tree species, we can free our mind to use them for ecosystem services on these locations. I did a lot of research on this for black cherry. I could give a complete presentation. I'm not going to do that, but we can see that it can become very important for biodiversity. Also for forest rehabilitation, as I explained to you what happened in the northern part of the United States. After a clear cut, it can very fast restore the forest, and underneath the black cherry can then grow the native species. It It will help us in climate adaptation. It's because it has a very, very large climatic range. If you see it naturally growing from Canada into Guatemala and from the Atlantic coast into the Midlands, where it's very dry, you can imagine that climate change will not harm black cherry as a population. So that again means that we have to learn to live with it. And as my very proud colleague here shows, that you can make very fine wood out of black cherry. This tree is selected at an age of 12. So this is it. I finished with a picture of a black locust forest near to Antwerp in Belgium. And the complete canopy is black locust, and there is a second tree layer, spontaneous developed, nothing got planted, by 2 acres, Castanea sativa and Tilia cordata, because there were seed trees in the neighborhood. And then you see that you get a very, very nice native forest. And then I have a question to you, especially to those who know the region here. Do you know any of such kind of forest dominated by ailanthus or with Acer negundo in the canopy that I could visit? Because these 2 trees I don't have enough experience, but also when you have very strong presence or dominance by Prunus serotina, Robinia pseudoacacia, or Quercus rubra, let me know. I would be glad to visit you and to go with you to this forest and to look how we could introduce this ecosystem resilience approach. Thank you very much for your attention.
Thank you, Bart. And now, if there are questions, we have time. Please, Alexander.
Thank you, Bart, for a very interesting presentation. About questions of forest of Ailanthus, Altissima, and Acer negundo, we don't have such forests where the both 3 species are together, because we know that they have different ecology, right? I see in our places and more further to Croatia that Ailanthus altissima is more on the dry thermophilic sites, and while the Acer negundo is more on the wet sites. So it would be hard to find them together. This is my opinion and my observations. The second, I'm very interested in information that you are dealing with forest Fagus orientalis under planting. Am I right that you are already planting Fagus orientalis? We all know this is a 3 species from Balkan Peninsula, from Bulgaria, Greece, maybe Serbia. It's more like ecotype. And if so, if you're dealing with it, where do you get plant material? Thank you.
We just started making experiments. We have besides this Resilias project, we have another live project, live climate forest, in which we are working on climate resilience of forests. And part of this is also testing new tree species. And especially a lot of these new interesting tree species that come from the Balkan, like the hazel, the tree hazel, and the Oriental beech and the silver linden. We did not yet have any experience with the planting itself. We are just starting this, but we found a lot of Fagus orientalis in the forest, especially in Germany. I know some stands of some hectares only planted by Fagus orientalis. And when you see then close to this stands of Fagus sylvatica, and I was there in 1990 and in 1920, and in the September after the hot summers, you could see that the Fagus orientalis is a lot more drought tolerant than the Fagus sylvestris. So that we learned from this, and then we start looking in the Netherlands, and then in the Netherlands also we found these planting of Fagus orientalis, but of those we are not really sure if it's not the hybrid between Fagus orientalis and Fagus sylvatica, because they easily at home I learned they easily can hybridize. There's even people who think that it's not two species but just one species. And we found them in the Netherlands, and then from the University of Wageningen, they did a research on the drought resistance of beech. And so all the beech stands from which they still knew the provenance, they looked at and they found a very large difference between provenances of beech in the climate resistance. And what was very typical, that the beeches that were the most climate resistant, they had these typical leaves of Fagus orientalis. So probably they are hybrids, and we know that in the past, a lot of seed for the beeches have been imported from Romania and Bulgaria. So we think it's an important tree species, and the important thing about Fagus orientalis, because it's so close to our own beech, it can take over the ecological functions. You're not introducing something very strange to the ecosystem. You're introducing something that is very close to the beech we are losing. If this is...
Other questions? Yeah, Anja.
It's actually not really a question, it's more a comment. So as Bart already said, we were also in the forest in Ticino yesterday, and what I find quite interesting is that often the money is given to fight the non-native species. So institutions or organizations, they provide money to eradicate non-native tree species, but so far it's not so common to provide money to, for example, plant new tree species, and so yeah, to restore the ecosystem, or yeah, to enhance this ecosystem resilience approach. So I think there's still a lot of convincing work which should be going on, also to explain that just fighting is not always the right way, and we spend a lot of money, which is often not worth it. And so yeah, I think it's a new approach and also a new thing for management, and it's quite a challenge to change this.
I would like to make a short remark to this. You have to be careful. At the moment that you start saying that you have a solution for your invasiveness problem, the money stops. Because there's no more problem. We had this very bad experience, and some of my colleagues got very angry with me because the management, the forest management money stopped. But if you see the solution, that does not mean that the solution does not cost a lot of money. I mean, if you want to make all these forest plantations in the northern part of Europe into a resilient forests, you need to plant a lot of trees. But it's, as Anja said, if you said, oh, we have a big problem, we have invasive tree species, we have invasive species, then you get easily your money. But if you say we want to convert this forest into a very resilient, stable, climate resilient forest, then they say, oh, that can wait for 10 years or 20 years or 50 years, probably it's not that big yet. So we really have to convince, as Anja said, people and governments and policymakers that there's a huge thing to do.
Okay, first there is René, then Katarina.
Hi, that's very interesting, Bart. Thank you for this knowledge. It's actually the answer is you have already answered it, you and Anja. I was curious because we know that the tree of heaven is said to be invasive by everybody, unanimously. And when you say that the tree of heaven is easy to be incorporated as your plants, incorporated into forestry, like are you also providing some management guidelines or management advices to it?
As I said, I'm working on tree of heaven now. I don't have any experience yet. That's why I ask who knows very nice tree of heaven forest where I could visit together with you, or from the properties of tree of heaven, you can deduce that it's very easy to integrate into forests. I have studied also the tree of heaven in China, and in China you see tree of heaven everywhere along the roads, along the railroads. But when you go to a very natural forest in China, and they have some huge forests which are strongly protected because there are temples in it and it's very holy, and so for the centuries they have. Then sometimes you see a huge tree of heaven, one or two, and very few, and the only young tree of heaven you find is where there has been a disturbance, where somebody has built a home and disturbed, or where there has been a landslide, and then you see rejuvenation of a group of tree of heaven. So it's really this pioneer tree species. But that does not mean that it will not be invasive in the city or along the streets. I mean, there you can't strengthen the resilience of the system. I'm only talking really about the forest ecosystem, and there I'm sure it's not too it's easy. But
there is this risk of you know, to the native biodiversity of the forest, right?
yeah, but I'm talking here about species that are everywhere in the landscape. Right? When you go drive here through the Po Valley, the Po flat side here in Italy, from Ticino to here, you see all the time tree of heaven everywhere. So if the thing that you accept the tree of heaven as a pioneer species in your forest will not make the pressure of tree of heaven on the landscape larger than it already is. It would be a different thing if you would introduce the tree of heaven. I would never introduce it. But when it's already there, you have to work with it.
Yeah, just one last point. Do you, in your opinion, do you think there should be specific legislations for non-native tree species in Europe?
Yeah, especially when you're talking about introducing new ones. Then you need a good risk assessment, of course. But putting the tree of heaven on the European blacklist, that is so stupid that I even can't talk about it. It's everywhere. It doesn't make a difference if you're going to plant it here in Italy.
Thank you so much.
Okay, Katharina, please, and then
Do you have
Florian.
time for somebody?
Thank you very much for the presentation. I think you present a very nice novel approach, which is very useful for forests. But I may not be 100% convinced yet, because
Very good.
I'm an invasive
Very good.
ecologist, and there I learned that an invasive species is invasive because it can be introduced to other ecosystems, and to maybe ecosystems which we cannot manage in this intensity like a forest. Or what happens if you stop the management of the forest for some reason? Can you still guarantee that it's not invading another ecosystem and so on? And there is no guarantee, sorry for this word, but you see, I just want to take on my invasion biologist hat and ask this question for you. Maybe that might maybe contribute to the reason why there is still such a big difference in like the funding for alien species management is so strong compared to the management of forest resilience.
Yeah, of course, all ecosystems you can't make resilience, like heathlands or grasslands, or they will still be invaded, but not only by these new species, also by our own native pioneer species. We spend a lot more money when we are managing our heathlands on eradicating birch and oak and pine on these heathlands than we spend on eradicating black cherry, even if the forest around is full of black cherry. And that is because the pine and the birch, they are spread by the wind. So there are seeds everywhere. The black cherry, for example, is spread by birds. So these birds, they need a tree to sit in to drop the seeds. And if there are no trees to sit in, it can happen then when they fly over, they drop a seed, but it's very, very little. So the difference, again, between the different species are important. And there's not really a huge difference between a native pioneer species and non-native pioneer species, those that we call invasive. And of course, there will always be this possibility of spreading from the forest. But that's also a reason why we say this ecosystem resilience approach, you only should use it for those tree species that are already widespread, that are already everywhere. Don't introduce an invasive tree species in a region that is not already there. That's asking for problems. So you have to take care. But if these tree species are everywhere in the landscape, you're not doing any harm to make them part of your forest ecosystem.
Good. Florian, maybe there was first Florian. Do you want to make it? Okay, Thomas, please.
Thank you for this inspiring talk. I think climate resilient forests is a nice concept, and on the first thought, I would say yes, it's okay to use all the species that are already there. But then my second thought is that you need to consider that there are differences regarding the host tree species for many insects. I mean, it's a difference if you look at black locust or we look at tree of heaven. So on black locust, there's almost the same number of insects like on our Pardus, which is closely related. But on tree of heaven, we don't have that high number of species of insect species. So it's, of course, it makes sense to stop the species to places where it hasn't invaded already.
Of course, and I'm not saying that we should stimulate these tree species. The only thing I see that is we can't eradicate them. So if and what I see at the same time is that nobody is constantly paying money for this eradication program. We in the Netherlands we started fighting black cherry in around the 1960s. Since the 1960s until now, we spent between 200 million and 500 million euros on fighting these tree species. And in my other presentation some years ago, I showed you that black cherry is in the Netherlands more present than ever now. The population is only growing, and we have been fighting all the time. So we know that we can't control it. So if you if you want to control it in the forest, you have an opportunity to control it by strengthening the resilience of the forest. That's what we are talking about. It's there, and we have to manage. We have to live with it. But in the forest, you can, by strengthening the resilience of the forest, you can reduce the impact of these species. Outside the forest, you cannot. There, you will have to go to continue to fight it, or you convert your open space into forest. What I would like to, but that's another thing.
How do you want to plant resilient forests if there are more and more disturbances around?
That's what I said. Then you have to adapt. Then the resilience against the invasive tree species and the resilience against the climate change, they go together. You have to mix them. It's one program. You have to think about how can we make a forest that under the actual and future conditions has a higher resilience. And then, of course, you are talking about other ways of management. No clear cuts, no large scale openings, but you're also talking about introducing other tree species that are more adapted to the new climate that is coming. And when these tree species at the same time are good competitors for your invasive tree species, you create a win-win situation. And this is what we have to study. We don't have a solution for everything, but this is the direction should be the direction of our researchers.
Okay, maybe Florian is the last question, then we can have a coffee break.
Okay. Well, thanks a lot. Also from my side, Bart, very, very interesting. Also a very nice discussion. Two aspects. Now, Thomas said Ailanthus, there's huge difference between Ailanthus and black locust because of yeah, its own ecosystem or insects or etc. But we also learned that over these 150 years, you explained to me yesterday, there was an evolution, so to say, and now there is even more insects on black locust.
No, on black cherry.
Black cherries, yeah, exactly. Sorry, black cherry, very important. Then on the well, native cherry species. Can this happen to Ailanthus? Do we know anything of that one? And in a second step here, I mean, thinking this forward would mean that we even have to proactively use some of these species that we are now still fighting in order to create new kind of resilient forests. Would you recommend some of these to be used actively?
Yeah, of course. I mean, at the moment that you have enough experience with these tree species that you know that they are not invasive, like this silver linden or Corylus colurna, there is no problem in planting them, and I would say it would be good to monitoring them. The reason for planting them now, even when the forest is still standing there, if we don't plant them now, you only can monitor, you only can see if they are really adapted, these tree species, when they are 50 or 100 years old. So if you don't plant them now, in 100 years, you still don't have anything to judge. That would be the reason for me to plant them. And I see that in Germany, for example, they use the red oak, what is on my list here of invasive species. They're planting red oak to enhance the resilience of the forest against the climate change. These are all things we have to think about, to study about, and in one situation you will make this choice, in the other situation you will make that choice. But if we don't start it now, we will be too late. It's just like with the conversion of the spruce. In the 1980s, we knew we shouldn't have this spruce monoculture because it was too dangerous. But it was so profitable, and everybody continued with these spruce plantations. And now suddenly we have a huge problem. It's a problem we knew for 40 years, and we had to manage it then in a different way. So let's not wait until it's too late before we start studying and strengthening this resilience of the forest. And to say about Ailanthus, like I said, I still have very little experience because in Belgium, Netherlands, my region they are not in the forest. So what we think, but I am studying now Ailanthus. If you see the amount of light Ailanthus needs, and when we strengthen the resilience of the forest against black locust and black cherry and red oak, these kind of forests, Ailanthus can't invade these kind of forests. These kinds of structured mixed forests, Ailanthus can't invade. If you see invasion of Ailanthus, always very open spaces or very open forests. And that was an interesting thing we learned also yesterday. There was in the Po where you have a lot of abundant agricultural land, and there was standing two nice trees of heaven besides this land, and all this in this land there was a spontaneous forest development on quite large scale of Ailanthus, I think like 20 or 30 years old. And then we were discussing with these Parco Nationale people about this huge problem. And after 5 minutes, we concluded together that we have a huge opportunity. Because in this dry region, they have if they want to plant new forests on agricultural land, they have a huge problem by planting because it's too dry and too hot to plant trees. Once you have this cover of Ailanthus, underneath this cover, you can easily plant your natural forest. So sometimes a problem can also become an opportunity. But as I said, I still have to study a lot about Ailanthus.